Hi, I'm Huang, and in this video, I'm going to discuss about acids and bases. So let's start. Definitions of acid and base. There are three definitions of acid and base: Arrhenius, Bronsted-Lowry, and Lewis. Let's start from Arrhenius. Based on Arrhenius acids and bases, acid is a substance that produces hydrogen ion when dissolved in water. The example is hydrochloric acid producing hydrogen ion plus chloride ion, while base is a substance that produces hydroxide ion when dissolved in water. The example is sodium hydroxide solution producing sodium ion plus hydroxide ion. So sodium hydroxide is a base. The second definition is based on Bronsted-Lowry acids and bases. Acid is a substance that can donate protons, while base is a substance that can accept protons. Example is hydrochloric acid plus water yields chloride ion plus hydronium ion. Here, hydrochloric acid donates hydrogen ion to water, so hydrochloric acid is an acid, while water is a base. The third definition is based on Lewis acids and bases. Acid is a substance that accepts electrons, while base is a substance that donates electrons. Example is calcium oxide plus carbon dioxide yields calcium ion plus carbonate ion. Here, calcium oxide donates electrons to carbon dioxide, which is the calcium oxide donates the oxygen to carbon dioxide, where the oxygen carries the electrons, while the carbon dioxide accepts electrons. So carbon dioxide is an acid, while calcium oxide is a base. Next, properties of acid and base. Acid. Acid tastes sour. It is corrosive. The pH is below 7. It turns litmus paper red, and it produces hydrogen ions in aqueous solution. While base, it tastes bitter. It is slippery. The pH is above 7. Base turns litmus paper blue, and it produces hydroxide ions in aqueous solutions. Next, chemical reactions that involve acids and bases. The first type of reaction is reaction of acid with a reactive metal. And based on the term itself, the metal should be reactive. So we need to look at the table of reactivity series. Okay, let's see the reaction first. Metal plus acid yields salt plus hydrogen gas. The example is magnesium plus sulfuric acid produces magnesium sulfate plus hydrogen gas. And the next example is copper plus hydronitric acid will have no reaction. This is because copper is not reactive and it doesn't replace hydrogen from an acid. We can know this by looking at the table of reactivity series. In the table of reactivity series, the metals are arranged in a decreasing order of reactivity, starting from the left. So, the leftmost metals, which are lithium, potassium, barium, calcium, and sodium, are the most reactive metals, while the rightmost metals, antimony, bismuth, copper, mercury, silver, platinum, and gold, are not reactive. So, to know which metals are reactive enough to react with acid and replace hydrogen from the acid, we should see the acid mark between lead and hydrogen. So the metals to the left of the acid mark are reactive enough to replace hydrogen from an acid, while the metals to the right of the acid mark are not reactive enough. That's why copper doesn't react with hydronitric acid, so there is no reaction. The second type of reaction is the reaction of acid with carbonates. Carbonate plus acid is salt plus water plus carbon dioxide. The example is calcium carbonate plus hydrochloric acid produces sodium chloride plus water plus carbon dioxide. For this type of reaction, we don't need to look at the table of reactivity series, and we only need to look at the reactivity series for the first type of reaction. Okay, next. The reaction of acid with bicarbonate. Bicarbonate plus acid produces salt, water, and carbon dioxide. The example is sodium bicarbonate plus hydrochloric acid produces sodium chloride plus water plus carbon dioxide. The next one is the reaction of acid with metallic oxide. Metallic oxide plus acid produces salt and water. The example is zinc oxide plus sulfuric acid yields zinc sulfate plus water. The next type of reaction is the reaction of acid with metallic hydroxide. Metallic hydroxide plus acid is salt plus water. Example, zinc hydroxide plus nitric acid is zinc nitrate plus water. Next is neutralization reaction. Acid plus base produces salt and water. The example is hydrochloric acid plus sodium hydroxide produces sodium chloride and water. Now, the reaction of base with ammonium salt. Ammonium salt plus base produces salt plus water and ammonia gas. The example is calcium hydroxide plus ammonium chloride produces calcium chloride plus water plus ammonia gas. The last type of reaction is the reaction of base with a metal salt. Salt 1 plus base produces salt 2 plus metallic hydroxide. The example is ferrous sulfate plus sodium hydroxide yields sodium sulfate plus ferrous hydroxide. Okay, let's move on to chemical calculations involving acids and bases. Let's start with the number of replaceable ions. It refers to the total number of positive or negative charge of the ions that compose a compound. For example, hydrochloric acid. Hydrochloric acid has one positive charge from the hydrogen ion, and it also has a total of one negative charge, which is from the chloride ion. So the number of positive or negative charge of hydrochloric acid is 1. So the number of replaceable ions is 1 equivalent per mole. This is the unit, equivalent per mole. The second example is sulfuric acid. So it has a total number of positive charge, which is 2, and the negative charge is also 2 from the sulfate ion. The positive charge is from the hydrogen ion. So it has 2 equivalent per mole. Aluminium hydroxide has 3 equivalents per mole because aluminium has a positive charge of 3 and the total negative charge is also 3 from the hydroxide ions. The last example is magnesium phosphate. Magnesium has a charge of positive 2 and there are 3 atoms here, so the total positive charge is 6, while the negative charge is also 6 from the phosphate ion, negative 3 times 2, so 6 equivalents per mole. The easy way to determine the number of replaceable ions is by multiplying the number of ions. So for hydrochloric acid, there is 1 hydrogen ion and 1 chloride ion. So we multiply 1 times 1 equals to 1 equivalent per mole. For sulfuric acid, 2 hydrogen ions times 1 sulfate ion becomes 2 equivalent per mole. For aluminum hydroxide, 1 times 3 equals 3 equivalents per mole. And for magnesium phosphate, 3 times 2 equals 6 equivalents per mole. Next is equivalent mass. It refers to the ratio between the relative mass of a given substance and its number of replaceable ions. Equivalent mass equals relative mass over the number of replaceable ions. Let's try to calculate the equivalent mass of the following. Number 1, calcium nitrate, which is CaNO3 2. So the number of replaceable ions is 2 equivalents per mole, and the relative mass is 164 grams per mole. So the equivalent mass is 164 grams per mole over 2 equivalents per mole. So it is equal to 82 grams per equivalent. So the unit is grams per equivalent. The second example is acetic acid, CH3COOH. The number of replaceable ions is 1 equivalent per mole, and the relative mass is 60 grams per mole. So the equivalent mass is 60 divided by 1 equals 60 grams per equivalent. Next is the number of equivalents. It refers to the ratio between the given mass of a substance and its equivalent mass. Number of equivalents equals mass divided by the equivalent mass. Example, what's the number of equivalents of 20.5 grams of barium hydroxide? So the relative mass is 171 grams per mole. The number of replaceable ions is 2 equivalents per mole. The equivalent mass is 171 divided by 2 equals 86 grams per equivalent, and the number of equivalents is the mass divided by the equivalent mass, so 20.5 grams divided by 86 grams per equivalent equals 0.238 equivalents. Next is normality. It refers to the number of equivalents of solute per liter of a solution. Normality equals number of equivalents over the volume of the solution. The unit is equivalent per liter, which can be set as normal, while molarity refers to the number of moles of solute per liter of a solution. Molarity equals number of moles over volume of solution. The unit is moles per liter equals molar, or just M. So normality can be calculated using molarity, and here is the derivation. Normality equals number of equivalents per volume of solution. The number of equivalents can be expressed as mass divided by equivalent mass, and the equivalent mass equals relative mass over number of replaceable ions. So we get mass times number of replaceable ions over relative mass times volume of solution. Mass over relative mass is also number of moles. So normality equals number of moles times the number of replaceable ions over volume. So number of replaceable ions times molarity, which is moles per liter, is equal to the normality. So normality equals molarity times number of replaceable ions. Let's go to the examples. Number 1. Calculate the normality of a 250.0 milliliter solution made by dissolving 150.0 grams of sulfuric acid in water. The given are volume, which is 0.2500 liters because we convert it to liters, and mass is 150.0 grams. So we need to find the normality. So let's start by finding the relative mass, which is 98 grams per mole. The number of replaceable ions is 2 equivalents per mole. The equivalent mass is 98 grams per mole divided by 2 equivalents per mole equals 1 49 grams per equivalent, and the number of equivalent is the mass divided by equivalent mass equals 3.061 equivalents, and the normality equals number of equivalents divided by the volume. So 3.061 equivalents divided by 0.2500 liters equals 12.24 equivalent per liter, or 12.24 normals. Okay, number 2. How many grams of acetic acid must be dissolved in water to produce 2.00 times 10 raised to 2 milliliters of 0.685 normal solution? So the given are volume equals 2.00 times 10 raised to 2 milliliters. We convert it to liters, it becomes 0.200 liters. While the normality equals 0.685 normal, and we need to find the mass. Let's start from the relative mass. It is 60 grams per mole. The number of replaceable ions is 1 equivalent per mole, so the equivalent mass is relative mass divided by the number of replaceable ions, so it equals 60 grams per equivalent. Because normality equals number of equivalents over volume, number of equivalents is equal to normality times the volume. So 0.685 times 0.200 liters equals 0.137 equivalents. Number of equivalents equals mass over equivalent mass. So mass equals the number of equivalents times equivalent mass. So the mass is 0.137 times 60 grams per equivalent. It is equal to 8.22 grams. Number 3. What is the normality of a 0.240 molar aqueous solution of phosphoric acid? So the number of replaceable ions is 3 equivalents per mole, because it is H3PO4, and we need to find the normality. The normality equals molarity times the number of replaceable ions. So it is equal to 0.240 moles per liter times 3 equivalents per mole. And the answer is 0.720 normals. And that's it for the discussion. Thank you for watching. Goodbye.